Hey, good morning, Saxon Geometry students. I'm picking up with lesson 2. I'm going to have to do this in 2 segments because I can't complete it in 10 minutes. So make sure you watch both segments. This is part 1. And actually, that's the name of today's lesson, is segments. Remember yesterday we did point, line, and plane. If you remember, a line went out to infinity in both directions and was established by at least 2 points. Today's lesson is on segments. That means we only want a part of that line. I want just the part of the line that falls between the 2 end points. A and B are the end points, and the segment is all the set of points that are in between those 2 end points. Remember, if you'll remember, under line, we could call that line L. We could call it line AB, and we would have written it like this. Or we could have called it line BA, with the arrows on the end indicating that it is a line that goes on forever. With the segment, it's very similar. We could call this line segment AB, or we could call this line segment BA, and we just use the flat little bar on top to indicate that we have a line segment. Now, something that's important in this lesson is the concept of congruency and equality. I'm going to draw 2 little triangles. Triangles are built with line segments. Here's our first triangle. I'm going to call this triangle ABC. And here's my second triangle. I'm going to call this triangle X, Y, Z. In the first triangle, I'm going to indicate with hash marks that the 2 line segments, AB and CB, have the same measure. That's what those little hash marks mean. In this triangle, I'm going to actually label it with numbers so that we know that the 2 line segments, XY and ZY, also have the same measure. And here's where congruency being congruent and being equal. It's a slight differentiation, but you need to understand it. Congruent uses this symbol. It starts out looking like an equal sign and then has that on top of it. An equal sign, you know what an equal sign is. Okay. In the first triangle, when we don't know what the exact measures are, I don't know what line segment AB measures, but I know it has the exact same measure as CB. So since I don't know the numbers, I say they are congruent. I say that AB, line segment AB, is congruent to line segment CB. And I indicated with that little bar on top that I don't know what the measures are, but I know that they're the exact same length. That's what congruent is. They're geometrically exactly the same, even though I don't know the numbers. Now in my second example here, I do know that XY is 6 units and ZY is 6 units. Therefore, I can just say that XY is equal to ZY. I don't even need to use the little bar on top. They are equal because I know the numbers. So maybe that'll help you. If you know the numbers, you can use the equal sign. If you just know that they're the same length, then you use the congruency sign. And that's the difference between being congruent and being equal. Now we're going to talk about some congruency, properties of congruence. Properties of congruence. There's 3 of them that we're going to talk about here, and I'm going to use a little picture to illustrate this. I'm going to draw 3 line segments. I'm going to call this one AB. I'm going to call this one CD, and you guessed it, I'm going to call this one EF. I have 3 line segments. I do not know the measures of these line segments, but I am going to mark them as congruent using a hash mark. 1 hash mark, 1 hash mark, 1 hash mark. So no matter how pitiful my drawing is, we have indicated with hash marks that they are all the same length. Now I'm going to talk about these properties of congruence. If I say that AB, line segment AB, is congruent to line segment AB, I know that sounds a little ridiculous, but that is considered the reflexive property of congruency. Reflexive property. Think of your reflection in a mirror. You see yourself. AB is congruent to AB. Anything is congruent to itself. That's the reflexive property of congruency. The second one then, if AB is congruent to line segment CD, which it is, then line segment, actually I'm going to write this out to the side so you can see this, then line segment CD is congruent to line segment AB. We just reversed them. We just made them symmetrical. This is called the symmetric property of congruence. Symmetric. We just put them in the opposite order. As a matter of fact, if I drew a line down here and folded this over on itself, CD would match up with CD and AB would match up with AB. They would be symmetrical with each other. So reflexive, symmetric, and then there's one more. And it's called transitive. And what that means is that if line segment AB is congruent to line segment CD, which it is, and line segment CD is congruent to line segment EF, which it is, then line segment AB is congruent to line segment EF. So if this line segment is congruent to this one, which it is, and this one is congruent to this one, which it is, then this one, AB, is congruent to EF. That's called the transitive property of congruency. And what will happen is that they will give you some line segments. Can you see that okay? They will give you some line segments and ask you which property of congruence. Does this represent reflexive, symmetric, or transitive? Those are new terms and new concepts, and like everything else, it'll just take us time to master them. Now, the final thing in this segment are postulates. We're going to be learning lots of postulates, axioms, and theorems in geometry. Postulates are accepted as true without any proof, and we're going to actually get to two postulates here in the next segment. But postulates, now remember, it's hard to remember this, so just think of this, that a postulate, I know it positively. I don't have to prove it. I know it positively. That's what a postulate is, and we're going to talk about two postulates in the next segment. I'm going to give you an example of one of the congruency postulates, properties, actually, congruency properties. And that would be, if I gave you this, line segment GH is congruent to line segment GH, and I asked you which congruency property does that represent, anything that is congruent to itself represents the reflexive property of congruence. And that's the type of problem that you'll see in the problem set. Okay, this pretty much ends it for this section. This is the first half of Wednesday's lesson. I'm going to start a new 10-minute segment for the second half, and we'll be talking about the first two postulates that we're going to learn. We're going to be talking about distance, segment addition, and midpoint. Okay?